Imagine a world hurtling through the darkness of space, completely alone, without a star to orbit, no sun to warm it, no light to guide it, just endless freezing void. Now imagine that world is devouring mass at a rate so extreme that every single second it consumes 6 billion tons of material. That's the equivalent of swallowing Mount Everest every 15 seconds. This isn't science fiction, this is real, and astronomers have found it. Before we get started, check out the link in the description to download our ebook. Today, we're diving into one of the most bizarre and fascinating discoveries in modern astronomy, a rogue planet called CHA 11077626. Yes, that's actually its name. And this cosmic wanderer is doing something that has scientists absolutely stunned. It's growing at a rate that shouldn't be possible for a planet, 6 billion tons per second. To put that in perspective, Earth's entire atmosphere weighs about 5 quadrillion tons. This rogue planet is consuming more than Earth's entire atmosphere every 24 days. So what exactly is going on out there in the darkness? Let's find out. First, we need to understand what a rogue planet actually is. Most planets, like Earth, Jupiter, or Mars, orbit a star. They're gravitationally bound to their sun, traveling in predictable paths through space. But rogue planets are different. These are worlds that either formed independently in space or were ejected from their home solar systems by gravitational interactions. Maybe a close encounter with another planet. Maybe their star died. Whatever the reason, they now drift through interstellar space completely alone. And here's the thing. Scientists believe there could be billions of rogue planets in our galaxy alone, possibly more rogue planets than there are stars. They're incredibly difficult to detect because they emit almost no light, no star to reflect, no internal heat significant enough to spot easily. They're cosmic ghosts, and we're only just beginning to find them. CHA 11077626 was discovered in the Chameleon 1 dark cloud, a star-forming region about 500 light-years from Earth. And when astronomers first observed it, they realized something was very, very unusual. This wasn't just a cold, dead world drifting silently through space. This planet was surrounded by a massive disk of gas and dust, and that disk was actively feeding into the planet. Material was spiraling inward, crashing down onto the surface or into the atmosphere at an absolutely staggering rate, 6 billion tons per second. Let me say that again, 6 billion tons every single second. This is accretion on a scale normally associated with young stars or brown dwarfs, not planets. And that's what makes this discovery so extraordinary. So how is this happening? How can a planet consume mass at such an extreme rate? The answer lies in that disk. CHA is surrounded by what astronomers call a circumplanetary disk. This is a rotating disk of gas, dust, and debris that orbits the planet, similar to the rings of Saturn, but far more massive and dynamic. As material in this disk loses energy, usually through friction and collisions, it gradually spirals inward toward the planet. Think of it like water circling a drain. The closer it gets, the faster it moves, and eventually it falls onto the planet itself. This process is called accretion, and it's how planets grow during their formation. But here's the key. Most planets stop accreting material relatively quickly, within a few million years of formation. Once they've cleared out their local environment or their stars, radiation blows away the remaining gas. The process essentially stops. But CHA is still actively feeding. The disk is still there, still massive, still funneling material inward at this incredible rate. This suggests the planet is either very young, still in the process of forming, or it's in an unusually material-rich environment that's allowing it to continue growing long past the typical planetary formation timescale. Let's put this growth rate into perspective, because 6 billion tons per second is a number so large it's almost meaningless without context. Every second, this rogue planet gains 6 billion tons of mass. In 1 hour, that's over 21 trillion tons. In 1 day, over 500 trillion tons. In a single year, CHA would accumulate roughly 190 quadrillion tons of mass. For comparison, Earth has a total mass of about 6,000 quadrillion tons. If this planet maintained its current accretion rate, it could theoretically gain the equivalent of Earth's entire mass in just over 30 years. Think about that. 30 years to build an Earth. The Great Pyramid of Giza weighs about 6 million tons. This planet consumes the equivalent of 1,000 Great Pyramids every single second. Mount Everest, the tallest mountain on Earth, weighs approximately 810 billion tons. This rogue planet devours the equivalent of Mount Everest every 2.5 minutes. It's almost incomprehensible. This discovery has enormous implications for our understanding of planetary formation and evolution. For decades, astronomers have studied how planets form around stars. We've observed protoplanetary disks, watched young planets carve gaps in those disks, and built sophisticated models of planetary accretion. But CHA is challenging some of those assumptions. First, it raises questions about how common this process might be. If one rogue planet can sustain such rapid accretion, how many others are out there doing the same thing? Could this be a previously overlooked phase of planetary development? Or is this planet truly an oddball, caught in a rare and fleeting moment of extreme growth? Second, this discovery blurs the line between planets and brown dwarfs. Brown dwarfs are sometimes called failed stars. They're objects too massive to be planets, but not massive enough to sustain hydrogen fusion like true stars. They typically range from about 13 to 80 times the mass of Jupiter. If CHA continues accreting at this rate, it could potentially cross that threshold and become a brown dwarf. Or maybe it already is one. This raises a fascinating question. Where does a planet end and a brown dwarf begin? Is it just about mass, or is it about how the object formed? CHA seems to exist in that murky middle ground, and studying it could help astronomers refine these definitions. Third, this discovery tells us that rogue planets might not be as dead and inactive as we once thought. We used to imagine rogue planets as frozen, lifeless worlds, abandoned and dark. But CHA shows us that some rogue planets are dynamic, evolving, and still very much in the process of becoming something. So what happens next? What does the future hold for this cosmic giant? If CHA continues accreting mass at its current rate, it could eventually grow large enough to ignite deuterium fusion in its core, officially becoming a brown dwarf. Brown dwarfs glow faintly in infrared light due to this low-level fusion and leftover heat from their formation. But here's the thing. We don't know if the disk will last long enough for that to happen. Accretion disks are temporary. They can be dispersed by radiation, stellar winds, or simply running out of material. It's possible that CHA's growth will slow or stop long before it reaches brown dwarf status. It might remain forever a planet, albeit an unusually massive one, drifting through space with the memory of its brief period of extreme growth locked into its composition. Another question. Could this planet have moons? With a disk this massive, it's entirely possible that material is clumping together within the disk itself, forming satellites that orbit the planet. Jupiter and Saturn likely formed their moons from similar circumplanetary disks. CHA could be building its own miniature solar system right now, hidden within that swirling mass of gas and dust. And then there's the biggest mystery of all. How did this planet end up here? Was it ejected from a nearby star system? Did it form independently in the chameleon dark cloud? And if it was ejected, what cataclysmic event sent it hurtling into the void, only to find itself surrounded by this mass-rich disk? We don't have all the answers yet, but that's what makes this discovery so exciting. CHA is a reminder that the universe is far stranger and more dynamic than we often imagine. Out there in the darkness, untethered from any star, a world is growing at a rate that defies our expectations. 6 billion tons per second. Every second, an endless cosmic feast happening in silence and shadow. This discovery opens up new questions about how planets form, how they evolve, and what happens to worlds that wander alone through the galaxy. And as our telescopes become more powerful, as our detection methods improve, we're going to find more objects like this, more rogues, more mysteries, more worlds that challenge everything we thought we knew. So keep looking up, because the universe has plenty more secrets waiting to be discovered. And who knows, maybe one day we'll find a rogue planet even more extreme than this one. Until then, thanks for watching, and I'll see you in the next video.